Dear learner, in last section we've learned about crystal structure and its Brillouin zone. Let's see now Miller indices for a crystal and family of directions and planes. First, have a look on Miller indices. Miller indices are used to specify directions and planes. These directions and planes could be in lattice or in crystals. The number of indices will match with the dimensions of the lattice or the crystal. For example, in one-dimensional lattice, there will be one index, and for two-dimensional lattice, there will be two indices, and so on. Let's see notation summary for Miller indices. Here we have to insert an information that Miller indices can also represent some points. The h, k, l, these are three integer values. These integers are enclosed by a parenthesis and separated by commas, can be represented for a notation system for a site or a point in a lattice. And negative numbers or directions are denoted with a bar on the top of the number. And HKL enclosed by third bracket represents a direction, and HKL represents by or first bracket can represent a plane, and the HKL enclosed by the second bracket represents a family of planes. And here the HKL, all these values are not separated by comma. And note that the exclusive notation for site or point can only use commas in this notation system. Miller indices for directions. Let's have a look at a picture inserted on the right side. These are lattice points in a crystal lattice. These points are equally spaced along vertically and horizontally. The axes are represented by A and B, where A represents the horizontal axis and B represents the vertical axis. And here we can denote A and B more precisely with basic vector. And this is a representation for two-dimensional lattice. Let's a random point O, let's take it as origin. And we have another point which is represented by a coordinate 4, -2. And the direction represented by these 2 points can be denoted by the Miller indices. Let's see. A vector r passing from the origin to a lattice point can be written as r is equal to a r1 plus b r2 plus c r3, where a, b, c, these three are basic vectors and Miller indices are r1, r2 and r3. And notice that these three quantity r1, r2 and r3 are not separated by comma, and they are enclosed by first bracket or parenthesis. That means it represents a point which is actually 4 - 2 point. And we know that the negative number or notation can be represented by a number with bar on the top of this value. That is, -2 can be represented with a number 2 bar. And the fractions in r1, r2, r3 are eliminated by multiplying all components by their common denominators. And here, for example, we have a site representing coordinate or Miller index 1, 3/4 and 1/2, and this Miller index for the site can be expressed as 432 enclosed by parentheses, and here the common denominator is 4. If we multiply this whole set, if we multiply this list 1/4 and 3/4 by 4 and 4/2, we get this simplified form as integer 432, and here R1, R2, R3, these can also be replaced by Miller indices H, K, L. Now let's see family of directions. We have seen that HKL enclosed by a square bracket represents a direction. But what if we consider the family of directions? It will be represented by this notation. And this representation will show us a parallel vectors or a family of directions. Let's see this picture. We have drawn a direction as from 0 or origin O to this point. Then we have similar direction, similar parallel. We have similar direction with parallel vectors, and these are represented by blue lines. All of these blue lines representing a set of parallel direction which is represented by the same HKL. Miller indices for planes. Miller indices can represent planes in a crystal lattice, and these planes are known as Miller planes. The procedure for drawing Miller planes is that first we have to identify the plane intercepts on the x, y, and z axis, and then specify intercepts in fractional coordinates. And the last one is take the reciprocals of the fractional intercepts. Let's see the illustration of these Miller planes. Consider a plane in a crystal lattice, which is one of the infinite number of parallel planes, is a consistent distance a away from the origin. Here we can see the axis representation from origin. This along x-axis, this is along y-axis, and this is along z-axis. And if we consider a along x-axis, we have a plane parallel to both y and z-axis, and which intercepts only on x-axis at a. This is the first more intense gray line, more intense gray plane in that case. Let's see another Miller planes for different Miller indices. Likewise, we can demonstrate the yellow plane by infinity, 1, infinity, and we can see green planes which can be written as infinity, infinity, 1 enclosed by parentheses. Miller indices are the reciprocal of the parameters of each crystal phase. Thus, here in adjusted picture, we can see the pink phase for 1, 0, 0 plane, the green phase for 0, 0, 1, and the yellow phase for 0, 1, 0. Let's see the demonstration of Miller planes using Materials Studio software. The software is getting ready to work out, and it's now ready to work. Let's take a new canvas select new, and since we are interested to demonstrate some Miller indices, then we have to draw 3D atomistic. We have to select 3D atomistic section and OK. Then for more simplified case, we can import the existing files of structures, and here we can see some examples and structure is available by default, and we have to open some of them. For more simplified case and to understand more easily, we are selecting metals, pure metals, and here a very well-known material as sodium. Actually it is cubic structure, and we can change our display style, select CPK and adjust the size of these balls. It's fine. 360-degree view. Here you can see all of these axes have same value along X, Y and Z. For a cubic crystal, A is equal to B is equal to C, and alpha is equal to beta is equal to gamma is equal to 90 degree. And here we can confirm this structure by observing this. Okay. Now for this structure we can demonstrate Miller indices and Miller planes using tools option. Select tools and here then select Miller planes, and here is a input section for our inputted value for Miller indices H, K, L. By default here is an inserted value 1, 0, 0, and if we create this structure and deselect all of these sections, show set of parallel planes, show symmetry image, and then create. Here we can see the plane. This is actually 100 Miller plane. If we change this value 110 and recreate it, see this is actually 110. If we want to see set of parallel planes, then we will get 3 planes as a set of the same value. If we want to demonstrate another representation for another Miller indices as 111 and create this, we will get some plane as this yellow plane. And if we are interested to demonstrate a set of parallel planes, here we can see 4 planes which are actually parallel to each other and represented by the same Miller indices. And if we change this value according to our interest, we can demonstrate different kind of planes in the same crystal. There is another representation for 112 Miller plane. Thank you, and these are the way to demonstrate Miller indices using Materials Studio software, and you can illustrate any kinds of plane for different types of inserted values in this section.